Hello and welcome to this lecture on VBA Unit 7. We're talking about structured programs in this lecture. The idea behind structured programs has actually been around for a long time in terms of software development. Going back to the 1960s, Dijkstra was the name of the computer scientist who was writing about structured code and writing code. And he made this observation that there are three basic structures. Sequential structures, like an assignment statement followed by an assignment statement followed by an assignment statement, or an input statement followed by an assignment statement followed by an output statement. Input hours, input rate, calculate pay, output pay. Those are sequential statements. And then there are iterative statements, statements that repeat themselves. A for loop, for next loop, for I equals 1 to 100, for I equals 1 to 10, it'll do it 10 times and repeat itself. That's a repetitive or an iteration. And then there is the selection statements, like the if statements. If hours is less than 40, then do one thing, else do something else. Selection statements can also include if, else if structures, and anything where you're testing and taking an action or a block of actions based on the value of a test. It turns out these three basic structures are sufficient to write all the software that all problems that can be solved in software can be solved with just these three basic structures. Now there's more than one way of doing an iteration than just a for loop. In fact, we'll talk about another loop structure in this section, today's lecture, and in this reading. And there's more than one way to do a selection than just doing an if statement. There's things called select case statements and other options. But they still have these three structures. A statement after a statement after a statement, and then a repeat or an iteration, and then a choose this or choose that. And working with these and piecing these together are how we write all the programs. So what we're going to do today is we're going to look at 4 problems that involve loops and if statements working together. And you're going to basically write the programs that I've given you. Next week, we're going to do more with these, but I'm not going to give you the answers in advance. You're going to have to work through those. So you'll spend the next assignment, Unit 8, you'll be spending a little more time on your homework. This one, again, is still drill and practice, giving you some code, typing the code, seeing how it works, write it, test it, read it, understand it, then write it, then test it, confirm it works. And I think that's the best way to master this code. By the way, professional programs, we're writing small programs in this class under 100 lines, even when we write our biggest programs at the end of the semester. Professional software is much larger. An iPhone app has about 10,000 lines of code. A military drone might have 10 million lines of code. But regardless, all those programs use this structured model. And it goes into something else called object-oriented programming that we will talk about later in the class that allows you to take 50 lines of code, 100 lines of code, 300 lines of code, and create a block called an object, and abstract that into even a higher level. But within the object, the code is still structured code like this. Okay, so let's look at some examples here where we're going to combine loops with if statements or decisions, right? Iterations and selections. So this example here on page 2, we're looking at even average and odd average. The program is to accept 5 input values, and some of the values are even, 2, 4, 6, 8. Some of the values are odd, 3, 5, 7, 9. And what you want to do is you want to average up all the evens and average up all the odds. And you don't know in advance how many of the 5 inputs are going to be even. You know at least one will be, but you don't know how many. You don't know how many of the inputs are going to be odd. We can assume that at least one will be an odd value. To do this, we're going to need to do 2 things. We're going to need to count how many even values and how many odd values there are, and we're going to need to accumulate or sum up the totals of all the even values and all the odd values. To get the average, we need a sum divided by a count. and we're going to use some variables in a special way. One is called a counter variable, which is variable equals itself plus 1. And the other is called an accumulator variable, which is variable equals itself plus a value. So let's look at the code, and I think it'll make more sense. So here's the code for the even-odd average. We are declaring 6 variables. I is an integer, which is typically a loop control variable. Value, which is probably what the user is entering. Even count, even sum. Odd count, odd sum. So to get the even average, we need the count, how many even values are there, and then the sum of all the even values, and that'll give us the average. Same thing with the odds. For I equals 1 to 5, input a value, please enter a number. I know that that input statement is going to happen 5 times because it's inside the body of this for next loop. So between the for I equals 1 to 10 and the next I, that's a block structure, and all the code between the for next is indented for visual help. The indentation doesn't matter from program execution, but it helps us visually understand that all these lines of code, this assignment statement, this multi-line if statement, is going to happen 5 times, when I is 1, when I is 2, when I is 3, when I is 4, and when I is 5. So this input box is going to happen 5 times. I is 1, I is 2, I is 3, I is 4, I is 5. And then after we input the value, we're going to test that value. If value mod 2 equals 0, that's testing if it's even. Because remember, mod is integer remainder. And if mod 2 is 0, then there's no remainder. It's an even value. The user entered an even value. If they entered an even value, we're doing 2 things. Then statement, statement, 2 statements. Even count equals even count plus 1. Even sum equals even sum plus value. When you have a statement like this, variable equals itself plus 1, or variable equals itself plus a value, another variable, then you have this idea of a counter variable or an accumulator variable. Plus 1 is a counter. So if even count was 7, even count equals even count plus 1 would make it 8, right? Because if even count was 7, 7 plus 1 becomes 8, and that becomes the new value for even count. So plus 1 is a counter variable. Boom, boom. 7 becomes 8, 8 becomes 9, 9 becomes 10. Variable equals itself, even sum equals even sum plus, and you're adding a value to it, not a constant 1, but a value, whatever the user entered, then that's more like a bucket. And every time the user enters a value, 12, 12 goes into the bucket. 24, 24 goes into the bucket. 17, 17 goes into the bucket. 3, 3 goes into the bucket. Right? So the variable even sum is growing by something other than 1 plus 1 plus 1. It's whatever the value is. So the terms for these are, and we mentioned this here on page 2, counters are variables being used to add 1 to itself, and accumulators are variables that are being used to add a value to itself. So we have a counter and accumulator for evens, and a counter and accumulator for odds. And after we get all 5 inputs, we go through the loop and we say the average of the even values is the even sum divided by the even count. And the average of the odds is the odd sum divided by the odd count. Here's what this program does when we run it. We can see